let me introduce our two speakers, if they need any introductions. So the first is, Andrew Ng is the founder of deeplearning.ai. He's a managing general partner at the AI Fund, founder and CEO of Landing AI, chairman and co-founder of Coursera, and an adjunct professor at Stanford University. And I believe he's teaching classes right now here. As a pioneer in machine learning and online education, he's really changed a lot of lives through his courses. I believe the number I have is over 8 million people have taken a machine learning course or taken an AI class from him. He was also the founding leader of the Google Brain team. He served as VP and chief scientist at Baidu. And he was also formerly director of the Stanford AI lab here. In 2023, he was named by Time magazine as one of the 100 most influential people in artificial intelligence. Right now, Dr. Ng focuses his time primarily on his entrepreneurial ventures, looking for the best ways to accelerate responsible AI practices in the larger global economy. So thank you, Andrew, for joining us. Mehran Sahami is the Tencent chair of the Computer Science Department and the James and Eleanor Cheeseborough Professor in the School of Engineering here at Stanford University. As a professor here, he is also the Bass Fellow in Undergraduate Education and previously served as the Associate Chair for Education and Computer Science. He's been very involved in designing and thinking about the computer science education here at Stanford. The last major kind of changes in it, Mehran spearheaded. Prior to joining the Stanford faculty, he was a senior research scientist at Google with research interests that include computer science education, artificial intelligence, and ethics. I'm hoping we also get to talk about that today too. And finally, he did serve as the co-chair of the ACM IEEE-CS Joint Task Force on Computer Science Curricula in 2013, which created curricular guidelines for college programs in computer science at an international level. He served as the chair of the ACM Education Board, an elected member of the ACM Council, and was appointed by the California Governor Jerry Brown to the state's Computer Science Strategic Implementation Plan Advisory Board. So thank you both for joining us here today. I can't think of two people more knowledgeable and more interesting to talk to about the topic before us.
Maybe, can I just add something? I think, you described Mehran's bio, lots of very impressive things. To people listening in that may not have attended Stanford, what you may not know is Mehran is legendary across Stanford campus, and there's a huge number of people that declared CS as a major. It's a very common story for Stanfordians. Come to campus, thinking of majoring in something else and not sure what to major in. Then they take Mehran's class and decide, you know what, I'm going to be a CS major. So that's why, and I think over the years, I've watched some of Mehran's videos on intro programming on YouTube and so on, and I've actually learned quite a few teaching tips from him. So Mehran may be the best intro to CS programming educator in the world that I know. And it's great to be chatting about this, Mehran.
Well, it's wonderful to be chatting with you, Andrew. It is a delight. You're far too kind. I mean, the way I think about it is students come to Stanford because they want a chance to be able to learn machine learning from you. And the kinds of things you've done in terms of democratizing education to the world through Coursera and other platforms is just incredible. So I very much appreciate what you've done to change the landscape of education, both in computer science and more broadly in the world. It's just incredible.
Yeah, thank you. That's very kind of you.
That's exciting. Yeah, and I should say, again, you have a chance to learn from both of them. I think, Mehran, you're still teaching Code in Place, usually every spring, so that if you want to get a taste of that Intro to CS class, Mehran teaches that. You can see, as I said, for both of them, you can see their lecture videos are available all over the place. Stanford Online has a lot of those, Stanford Online on YouTube. And Andrew, I'd say your machine learning lectures on those have over 1 million views for just, things like intro to linear algebra for machine learning. So people are learning a lot from both of you. So thank you again. Before we jump into education, though, I think that maybe the place to start right now, and I'll start with you, Andrew, is, with the recent advent of LLMs or the recent sort of widespread use of LLMs, how have you seen the profession of coding and software development changing?
Yeah, so AI is a general purpose technology being applied to lots of fields. We just saw actually today announced the Nobel Prize in Chemistry awarded to Demis and John and David Baker from UW and Google for applying AI to chemistry and biology. And was just yesterday that physics award Nobel went to Jeff Hinton and John Hopfield. But so AI is having a huge impact on lots of other fields. But I find particularly exciting as a software engineer or developer myself, the impact that it's having on our field. And maybe I see, if I were to try to synthesize all the stuff happening, the most exciting trend I'm seeing is things feel like they're moving faster than ever. In two ways. One is experienced developers are using Gen AI in many ways. Software developers coding, we do many different things in our jobs, and for a huge range of things, from writing documentation to generating code to debugging code to writing test cases to brainstorming architectures. For a lot of the tasks of software, professional software developers, Gen AI is really helping. And then the other trend I see exciting, maybe even more exciting, is helping to bring a lot more people into software engineering. You no longer need to remember the details of the syntax of exactly what, weird incantation you need to say in your code to make a computer do that one thing. But tools are being used to let many people learn a little bit and in a low code fashion, very quickly build compelling applications that previously would have taken, I don't know, many months or even many years to learn enough to build. So bring a lot more people to CS. So it feels that the whole field is moving much faster and a lot more software is being shipped.
That's really interesting. So you're kind of seeing on two levels, both the very experienced programmers using it to be more efficient, to get more done, but also people without much programming experience being able to write sophisticated programs. Mehran, can I hand it over to you to kind of follow up on that same question, but maybe from an academic perspective or for when you're sitting at Stanford? How do you see generative AI changing the kinds of research or the things that you're seeing happening at Stanford?
Sure. I mean, I think to dovetail on what Andrew was saying, one of the things that's right on is thinking about the industrial needs, how that transforms, or the way we think about that in terms of education at the post-secondary level and in college in general. For example, a little while back, was involved in a conversation where Kevin Scott, the CTO of Microsoft, was there. And one of the things he was talking about is the widespread use of tools like Copilot at Microsoft to help their programmers all become more productive across the company. But one of the things he mentioned that was interesting with respect to academia is the expectation in industry that students coming out of college, in the next 1 to 5 year time frame would have these kinds of skills as part of their education for developing code. So it's not just something I think that is a luxury of whether or not we think about this, but it's really a necessity in the toolbox of training students at the collegiate level to be effective software engineers. So that's how we think about it. This is not a question of if we do it, it's a question of where and how we do it. And what I mean by where and how is what is the right level at which we engage students with these tools as part of their educational process. And how does that change what we think of as the traditional pipeline or the traditional ways that we structure our topics in computer science education versus when's the appropriate place for the tools. And I think that debate is not yet entirely settled. There's people looking at different places where that might happen, everywhere from it should happen in the very first course that students see to it's a tool that should be introduced near the end when they're doing sort of a large project that they're trying to wrap up their degree with, and pretty much everything in between. So, we're looking at a few different models for that at Stanford, but I would say it's really just a matter of when we do it and where we do it, not if we do it, because the changes are that pervasive.
Yeah, and one of the most interesting things that I see across a lot of academic institutions in CS and other disciplines is trying to forecast where the future of work is going. Because, in education, first, we don't want to train people for yesterday's jobs, but in addition to training people for today's jobs, we also sometimes want to make sure people have the skills to do the jobs that will be around, 2, 3, 4, 10, 20 years from now. And then with the rapidly evolving Gen AI, I think it's clear in the future, many developers, maybe all developers should use Gen AI because you just be more productive than not if you use it. But the tool chain is evolving so rapidly that forecasting exactly what are the fundamental skills to teach that will be generalizable and important for a long time versus the things that may change quickly, that's been challenging. And I think as an example, I think VS Code, GitHub Copilot is great, fantastic tool, huge productivity boost. And then we have tools like Cursor that are very good at providing the line-by-line changes to the code and let you approve or reject. And then was it just last week or a couple of weeks ago? OpenAI Canvas, again, really nice, generate code and then have it, edit the codes. And I find that effective use of these tools, it does take a little bit of training to know what to do, when to trust the code or not. And maybe one thing that, I learned from friends this many months ago was if I'm giving code that, I used to be giving code that to read through the function, figure out what this actually does. But it turns out if you type /* in C++ or # if in Python, have GenAI write a comment for you to document the code for you, that saves you a lot of time. Instead of reading all the code, have it write a doc string or write a comment and just read a comment, because the GenAI can read all the code and describe it much faster than I could read the whole function myself. But that's just one tiny example. I think there's so many tips and tricks that having developers learn these processes of using GenAI feels like there's actually a lot of work ahead, and the best practices are still evolving, and the tool chains are also evolving.
That's really interesting. Go for it. No,
I was just going to say, to dovetail on what Andrew said, because I think he has great insights, when he kind of looks at where the future is going for these things, is exactly the symbiosis that the tools are not just giving the programmers code to make them more productive. The tools are also teaching the programmers about things. So when a programmer, is working with a new language, for example, and wants to figure out how to do something there and sees an example of it that's generated by a tool, it's not only about, okay, now they're more productive because they have that piece of code that they can insert in their code base somewhere, but they're in fact learning through sort of literate coding, right? They're actually seeing the stuff that's produced, or they're asking, as Andrew said, like for comments to be generated on it. And just the process of using these tools actually becomes a learning experience for the programmer. So we actually get these two effects there for productivity. One is the code generation itself. The other is actually the long-term learning that's happening as a result of using the tools.
Actually, that's a great point. A couple of months ago, I was trying to code up an open source thing myself. If it works, we'll release this open source at some point, but it doesn't matter. But one of my friends, Lawrence Moroney, who's ex-Google, pointed out to me that one of the ways that developers get a lot of benefit is there are these design patterns for coding that certainly I'm not that familiar with. Mehran may be more familiar with them. But one was a couple months ago, I was working on an open source project, not yet released, and I was trying to figure out how to architect the code. And GPT-4 told me to use the factory method, which is a specific design pattern in object-oriented programming that candidly I don't use that often. And I just hadn't thought of it. But with a mix of GPT-4 and Claude 3.5, wound up, architecting the code using a factory method, which is actually much better than the thing I was doing before. And it reminded me of what is the factory method design pattern. Those of you interested, you can search online if you want. Is a object-oriented design pattern to instantiate objects that without knowing exactly what class they'll be. And it was a much better solution than I had coded up. And I think many of these examples that we use a GenAI as a brainstorming partner will help us better understand pretty core building blocks, especially things that we may not use every day. And syntax as well, right? There are libraries that there are a lot of libraries like pandas for manipulating data, Streamlit for front end for a lot of machine learning applications, where I love the libraries, but I just can't remember the syntax, frankly. And I used to have to look up documentation every single time, but now I don't even try that hard to remember the syntax. Have GenAI write the code, and it feels like we evolve into this interesting paradigm of almost generate and test, which is a little bit dangerous. And I think best practices are still evolving, but the generate and test paradigm, generate and verify and maybe test paradigm, is letting a lot of teams get the software written much faster, and sometimes high quality, sometimes low quality. Maybe that one's still not yet determined.
I mean, those are both really, really interesting points you're raising, and I guess, Mehran, to come back to you in terms of thinking about the curriculum, I mean, where, Andrew, you were saying a lot of experienced developers are using these tools. Well, they already have a really strong foundation in computer science. So when you say, hey, you should use the factory model, you understand at some level what that means, and you can evaluate it. So what are, Mehran, what are you thinking about? What are the foundational skills that will still be there, that computer science majors will still be there, need? I mean, do you still need to have probability? Do you still need to have a basic algorithms class and really understand and understand how to build an algorithm? So I guess the question to you, Mehran, is just what are those foundational skills that you still see that are really important in order for you to be able to use those tools, not in terms of the interface with the tools themselves, but to evaluate the work and to be a thoughtful co-brainstormer with those tools?
Sure. I mean, it's a great question. It does kind of get to the point of, do we get sort of a generate and test or generate and verify paradigm with the generative AI tools? One of the things in the thinking that we've been doing is it's critical for students to understand the code that's generated for a number of reasons. One is to be able to verify that that code is operating correctly, more or less, in terms of the problem they're trying to solve, that in fact the code is appropriate for the problem they're trying to solve. And kind of as Andrew just alluded to, when you think about different ways of solving a problem, their efficiencies, the architecture, how it kind of fits in, having that level of taste in programming to know what is better and what is worse when you're making your decisions around what you're building. And so you need to have some experience with programming before you can make those decisions well. So for example, we would not count on students in the very first course to just generate the majority of their code using these tools. In the first course, what we want to do is we want to teach all the foundational skills of thinking about what are some of the main concepts in programming, how do you put them together in a particular language. We teach Python right now in our first course, but we've also taught that course in C, we've taught it in Java, we've taught it in Pascal. Concepts all remain the same, although the syntax changed by language to language. And what it tells you is that there's these foundational concepts in programming that are important for people to know that live in some sense parallel to the syntax of the language that they're using to solve their problem. And so those foundational skills, oftentimes we think about in terms of programming style as well. What does it mean to take a large problem and break it up into small pieces? What does it mean to define the interfaces between pieces of your code that are working together to keep things modular and to not scale complexity as you're building the system? How do you actually sort of mentally model a piece of code's execution to be able to verify that it works or debug it or find issues in it? Those are all foundational skills. We think it's certainly in the first course and probably in the second course are things that are not going to change a lot because students need to learn them. When you move beyond that and say, okay, now you have those skills, now you can have someone present a piece of code to you and be able to go through it and really dissect it and figure out, are there better ways of doing this? Can I debug the code? Whether that code was generated by a human being or by a machine, in some sense, doesn't really matter. You just need to bring those skills to bear to be able to think about how you understand that piece of code in a better way and its role in a larger system that you're architecting. So that could be the third course all the way through the nth course, where the nth course is like a senior project or whatever that students do at the end of their undergraduate degree, or a capstone, say, that they do in high school. So we think that there's lots of touch points along the way, but you need to have a solid foundation on things that's probably not going to change a lot for the first couple courses, but then beyond that, you have a lot of room for growth.
Andrew, is there anything you'd want to add to that? Anything you've seen in your own practice or people you've worked with in terms of those foundational skills that you think are going to, that are absolutely essential for just evaluating the products of generative AI in terms of coding?
Yeah, so I agree with Mehran. A lot of the core foundational building blocks are still important. And let me illustrate this with one example why. Maybe someday we'll have some wonderful AGI that could do anything a human can, and then we don't need to think about these things ourselves, but that seems really far away. But I think one of the bottlenecks of getting AI systems today to be more intelligent or make better decisions or whatever is that they're still often lacking a lot of context about why we do certain things. And humans have a lot of context that for whatever reason, is it data plumbing or whatever, but for lots of reasons, AI today is just missing a lot of context. So for example, maybe another example, I was coding up some things like a couple months ago. It was really slow. I decided to implement a cache. I've forgotten the syntax for how to call a certain Python module cache, whatever. I had GenAI do that for me. But I reflected, I needed to know that there's such a thing as a cache or memoization, so I could get an AI system to just write the code for me, which it did perfectly to use a cache. But I had not known that there was such a thing as a cache, which, Sunset taught in intro to CS types of courses, I wouldn't have gotten that job done. And I think the reason that, I, in that example, played a helpful role to getting to a better piece of software was I had the context that let me make a decision that the software was too slow. And I don't know how much plumbing and data infra would have needed to give the GenAI the context of what's important about the application, that reasoning, draw that conclusion itself. And then second, I think, I knew we had access to this. I knew space wasn't a problem, so I could make a really quick decision. Let's just see if we can implement this with a cache. But the context that went into that decision of let's do this and not that to build a cache as well as some other thing, that was actually a complicated decision. Maybe someday AI has enough context, enough background knowledge about what are the resources, what's important to reason through and make more of these decisions, then maybe humans can step back from those high level decisions. But good software engineers, good software architects have an amazingly broad span of context about what's possible and what they're trying to do. And until we manage to digitize all that context and get into Gen AI and also improve reasoning, I think we just need humans to do that for quite a long time.
That's interesting. Mehran, maybe building on that, let's say it's now 5, 10 years in the future. You're here, you're overseeing the CS curriculum, you're looking at students. What are you going to be sad that they're no longer able to do? I mean, there's always this fear of kind of some level of deskilling that might come along with it. And maybe that's not bad. Maybe that's good. If you're not doing that, you're doing something else. And I think in particular, there was an interesting comment, and maybe this is a little bit tangential to this, by one of your former colleagues, Daphne Kohler, in a recent talk she was giving, where she said, in terms of machine learning, that one of the things that had fallen by the wayside with recent advances is the ability of researchers to really think deeply about how to map a particular problem onto a model, how to map it onto a machine learning model. Because right now you can kind of just throw data at a problem, but especially as you move into more data sparse areas like physical systems or machine learning, or autonomous vehicles, those kinds of things, you're still going to really need to have that skill to think deeply about how to map a problem onto a particular machine learning model. So that's my way of saying, what are you going to lament? What do you think is going to be lost in this? Again, for better or for worse, in the next 5 to 10 years.
Right, and I mean, it's a good point. I think for me personally, I should think to lay the context. I see a lot more upside than downside. And so what I would say by that is, when I was an undergrad, we were all required, everyone in the computer science program at Stanford, to take a course on machine language. Right, because that's just one of the things you needed in terms of if you're going to speed up particular things in the machine. And I thought it was an interesting course. It was a fun course. I do not lament that students don't have to learn. Right, we have progressed to a place where students can think about higher level issues and have that kind of stuff well optimized for them. So I don't lament that loss. What I potentially lament is as these systems kind of get architected and built out, are students, do they have the taste, like Andrew mentioned, to think about what are some of the things that can actually, a concept that can have a big impact on their code? That's what I hope doesn't go away. Caching, big concept that can have big impact on your code. Parallelization, concept that can have big impact on your code. So these are the kinds of things that I don't want people to become complacent, to say that everything's going to get handled for you. The machines are getting smarter. So I can envision a world in which we just basically move higher and higher up the food chain in terms of what we need to worry about. But I hope we don't lose sight. I hope there's always people who kind of think about these foundational concepts of, hey, we could think about this low-level thing in a different way, and that might speed up everything that happens higher in the stack. But I think the reality is we don't need everyone to be doing that. There needs to be some people that specialize in that, and everyone else can benefit from the things they do. It kind of reminds me of this example from Facebook when it was still called Facebook rather than Meta, as they were using PHP as their programming language. They had a team that just worried about optimizing the implementation they had of PHP. And the interesting thing is any gains that they got on performance, everyone else in the company got to benefit because they were just sitting on top of that stack. And there was actually times, I remember Mike Schrepfer, was their CTO at the time, saying, there were times when they were thinking about machine provisioning quarter to quarter in terms of what their projected needs would be, and their projected needs would actually go down in some sense from what they already had because the efficiency gains were so high that now they had a whole bunch of machines available to them that were just essentially being used for executing code. So I think that's potentially a world we move closer and closer to as these tools get smarter and smarter in some sense. But I don't want to lose the fact that there's still people who are working at a very low layer who are helping create these optimizations for everyone who's benefiting on top. If we're all sitting on top, then eventually we're going to lose that optimization level underneath.
Andrew, is there anything, I have a follow-up question for you, but anything you'd want to add to what Mehran just said?
Yeah, I think Mehran put it very well. One of the reasons CS has made so much progress is with multiple layers of abstraction. From quantum physics to transistors to semiconductors to assembly language to low-level, high-level programming languages, and in AI, we then have learning algorithms, foundation models, applications. This is a huge stack. And I think having people, and today we still have people worrying about quantum physics and the physics of transistors, which is great. So people working on all layers of the stack. One thing I've learned is that when there's a new technology, then the ability to peer a couple layers lower is helpful. So for example, with large language models right now, which are relatively immature, there are orchestration layers that help people manage the workload built using LLMs. But because it's still not really mature technology, if you can break through that abstraction layer to go a layer deeper, you can often get better performance. But assembly language may be one example where once upon a time, ordinary mortals could write assembly code better than the compiler. But honestly, today, I would not want to compete with a compiler in optimizing any code anymore. Some people can, but not me, right? And so we just operate only a high level of abstraction. And so I think this dynamic of building up layers of abstraction, and sometimes you do want to teach people a couple layers deeper so they can, maybe one example, most of the time I don't worry about my sort function, just call someone else's library to sort something, it works just fine. But it turns out if you're sorting really large files that need to swap to disk because they can't get memory, then understanding how sorting actually works, it could actually help you think through how to architect a sorting thing. That's kind of a corner case. Now, most time, don't worry about sorting, but there are some corner cases of really, really massive data sets where understanding how sorting actually works still drives better performance today. But I think, so one thing about computer science departments is I think as the layers of abstraction move up, to keep on moving up the stack and then being thoughtful about how deep to ask everyone to still go. Because sometimes it's useful and sometimes it becomes less useful.
It's really that's really interesting. I want to come back to these layers of abstraction, but Andrew, just as kind of staying with you in a follow-up there, when talking about how AI will impact, and in particular generative AI will impact jobs, you have what I think is a really useful framing, as you say, don't think about jobs, think about the tasks that you're doing and how that will influence the tasks. And I was hoping you could talk a little bit more about that, and in particular, what I'm hearing from both of you is there may be a world where in a few years, maybe I'm doing a lot of the things where I'm trying to find a computer science student at Stanford to do, hey, can you write a web scraper for me to find these things and compare our site to Stanford's to make sure we're not out of sync? Maybe in the future, that kind of program is just now offloaded to someone who doesn't have a strong computer science background. And I'm just thinking through the task in the same way I write the instructions for this student, and I put it in LLM and they write it for me. But then there are people, so a lot of those low levels are going to people without that formal education, but it's a new task that's now within my kind of bundle of tasks in my job. And then the people who are the computer scientists are thinking at that deeper level of abstraction and thinking of how to optimize. So that was a big question, Andrew. So I guess just in terms of how you're thinking about AI to impact these jobs and thinking at that task level, if you could elaborate on that.
Yeah, so and I actually want to credit Eric Brynjolfsson and some of his colleagues, Tom Mitchell, I think Daniel Rock, some others really pioneered the task-based analysis of jobs. And it turns out at societal, government, academic level, we worry about AI automating jobs. And from helping individuals identify opportunities, I find it more useful. Really, Eric taught me this. Take a job, break it down into the tasks, see what tasks AI can automate or augment. And one thing I'd love to see is, I think I really want to encourage almost everyone in the world to learn to code. I think it'd be worthwhile for definitely many knowledge workers, maybe, pretty much everyone. And I think, one society wondered if everyone should learn to be literate, right? There was a view that, you don't need to learn to read and write, just let other people do all the reading. And fortunately, we've moved past that. Today, we still wonder if everyone should learn to code. And I think the answer is yes. I plan to my kids are a little bit young. I plan to teach them to code when they're a little bit older. And that's because the ability to precisely tell a computer what you want the computer to do for you, to me, that's the heart of coding. It's not about syntax. I love Python, but it's not about the Python programming language. It's about the skill to take a problem, break it down, and systematically tell a computer what to do. And I do see a strange almost convergence between, just a little bit, not to overhype it, between English and Python, where my Python code now has a lot more English in it because I'm writing prompts to tell an LLM what to do. And then also when I'm writing English for LLM, there's this structured step-by-step, like do this, that my English looks a little bit like pseudocode. But I think the heart of programming is being able to precisely determine and then also tell a computer exactly what you want it to do. And I'm seeing many people in many job roles that are not professional software engineers. I'm seeing one of my teams as a marketer that actually wrote code to scrape websites to help him gather intelligence on marketing insights. So one of my team members is a reporter that's been writing code to help him flag to him when there are interesting stories that he needs to pay attention to. One of my team members is an investor that's writing code to try to automate generation of legal contracts. So I see a lot of people whose job role is not software engineers, but with Gen AI as a coding companion, it becomes much easier for everyone to code just a little bit, and this drives a lot of productivity in a lot of job roles.
That's really interesting. And Mehran, I have another follow-up. I still want to put a pin in this, the higher levels of abstraction, but building off what Andrew said, I know you've talked a lot about, and I think this was part of that original kind of redesign of the Stanford curriculum that you spearheaded about 10 years ago, is computer science is kind of computational thinking and how you break down a problem. And so I wonder if you could build on Andrew, as you're thinking about those intro computer science classes. It sounds like it really is what you're trying to train them is how do you think about how these systems work? How do you think systematically and break it down? And I love that you're all talking about literate programming too, because that's Don Knuth, also a Stanford professor, right? That was kind of his big push back almost, I think it's 40 years ago.
Yeah. I mean, that's one of the things, to keep in mind is you see these themes come up over and over many years because they're important, right? And when we think about, for example, teaching programming and how we consider the notion of what that curricula looks like, or how we think about the evolution of the skills the students have. In the first course, one of the things that I actually tell students that freaks them out by the end is, 10 weeks into the quarter, they've gotten a whole bunch of Python, they've gotten all this programming. I get up there and I say, this was not a class about programming. And they're like, what are you talking about, right? We just did programming for last week. And I said, yeah, this is a class about problem solving. And, we told you about Python, but really what we were trying to get you to understand is how do you take problems and think about them systematically? Similar to what Andrew was saying, how do you break them down into smaller pieces? How do you tackle those smaller pieces? How do you put them together in solving a larger problem? This is things that we do in the world to solve big problems, right? We're not going to solve climate change because one individual does something. It's a bunch of pieces that all need to be put together in more systematic ways to think about greater solutions. Programming is a way to be able to codify that notion of thinking in a way where we describe it to a computer to be able to execute, but clarifies for us our own thinking, our own problem solving, our own decomposition of problems. So I think when we think about the role of generative AI in this, it's sort of in some sense a symbiotic partner that helps us with thinking about what are different ways we could break down problems. When we break them down to a particular level, the level we need to go down to be able to solve that problem maybe isn't as low level as we did before to actually have to generate the code ourselves, which empowers a lot of people to be able to think about what are some of the smaller pieces that I can contribute to. And so I think what we provide is basically just a level of empowering. The thought processes we think about in terms of coding as problem solving or coding as computational thinking, or those things are going to remain. The tools that we have available now to us through AI to think about what those pieces are, how we actually craft them, and how we put them together just essentially gives us more power tools in the arsenal. So I'm, pretty excited at multiple levels for what this does, to get back to the point that it's not just about programming, it's really about clarity of thinking, because you have to describe to a computer at a level that is clear enough for it to execute. That level of clarity of thinking is also something that I think is just important in general communication between people.
That's really interesting.
I'm going to say something, maybe go out on a limb, say something that may be a little bit weird, but there have been fascinating studies that seems to suggest that when you train a large language model, if you train it on code as well, it becomes better at other tasks as well that are not coding related. And I think recently OpenAI's O1 model, Strawberry, right? I think a lot of the development work was on coding and solving math puzzles, but I feel like it's actually really good at non-coding and non-math puzzles. So if you believe this evidence, flaky evidence, this is not the hill I would die on, there's maybe evidence that generative AI is better at other problems after learning to code. And part of me wonders if this may be true for humans too, that learning to code teaches a framework for breaking down problems, solving things in a step-by-step way that maybe helps people solve, even other problems. So maybe yet another reason to encourage everyone to learn to code.
So to add another data point to what you're saying, because, I think that's a great point. It's actually not that freaky. It kind of, it has some intuitive sense behind it. Carl Wyman, we were talking about the Nobel Prize before. Carl Wyman's a Nobel Prize winner in physics and spent sort of the second half of his career focused on education and really bringing sort of scientific method discovery to education. He had this study a few years ago, which was fascinating, where he had this little problem, which was about essentially learning kind of like a circuit function. There's some inputs that come in and some inputs that go out, and trying to get people to understand what that circuit was doing. And he had a whole bunch of different students from different majors try to like understand this and figure out what was going on. And he said across a whole bunch of different majors he looked at, I think including electrical engineering, like the performance was all the same. And then he got to the computer scientists and they were just like markedly different. And so he sends me an email and he's like, so what are you teaching over there? Like, what is going on that these kids are just like performing like 2 standard deviations away from all their, I mean, the other people were like Stanford students, right? They're smart people in general. And I was thinking about it for a while and I was like, I think the thing that we think about is systematic thinking, right? Like that's a computer is executing things systematically. And so as the human being, if you want to model that execution in your head, if you want to think about how mechanisms work in the world, you think about how do you approach them systematically? What's the execution model? How do inputs map to outputs? And so if a computer in some sense is kind of learning some generalization based on that, it's not actually surprising that it might carry that generalization into other tasks.
Yeah. That's really interesting. I want to maybe Mehran, move away from kind of this going deeper and look at what you talked about, going to these higher levels of abstraction. So I know a big part of just movements in general in computer science education, but a lot of what you've been doing recently in terms of your teaching is bringing a lot more discussion around the kind of societal impacts and not just thinking of computer science as just kind of just purely programming, but of how can you use computer science to solve these bigger social problems. And so can you say a few words about what you've been doing, what's been happening here at Stanford in terms of thinking about things like ethics and social impacts of computing and what role, how that might be changing in the face of generative AI?
Sure. I mean, one of the things we want students to think about is as computer scientists, as programmers, you have these immense power tools at your disposal, and the scale of those power tools is just increasing as a result of generative AI. So it behooves you to understand what are the implications of the stuff you're building, who's being impacted in what way, what are those distributional effects, different groups are being impacted differently. And so one of the things that a program that we've started a few years back now that's actually modeled on a program at Harvard is called Embedded Ethics, where in a number of classes, including the machine learning classes that Andrew helped pioneer, there are modules in there that say, in the context of this technical work that you're doing, here is a particular social issue that comes up, whether it be sort of fairness and algorithmic decision making, whether it be issues around privacy and how data is maintained or what kind of rights people have over their data. Whether it be about the choice of your optimization function, the thing that you're optimizing has different kinds of consequences for who gets impacted, et cetera. Embedding those kinds of things as part of the curriculum so that students can see that part of their in doing their technical work, it has social implications, and that they can carry that forward to think about in the work that they do out in industry, out in the world, or as academics, as researchers. There are social waves or social ripples that come out of the work they do, sometimes direct, sometimes indirect. And having an understanding and appreciation of that allows for making better decisions with respect to what kind of problems you want to solve, how you want to deploy that technology, what kinds of safeguards you want to put in place.
Yeah, actually, maybe just to add to that, I saw with my own eyes many years ago, Mehran was working to infuse this type of responsible AI, responsible CS throughout the CS curriculum. And this was long before AI safety became a thing. I feel like, unfortunately, the term AI safety has been co-opted to, largely or partially refer to kind of science fiction doomsday scenarios. Whereas what I saw, and Mehran actually co-authored the book Systems Error, right, that talked about some of the real practical issues and how to take real actions to address, actual problems of bias and systematic errors and so on. And I think it's kind of unfortunate that part of AI safety went off in this science fiction-ish, evil killer robots, doomsday, I don't know what. But I think there is important work to be done. And just, I saw with my own eyes, Mehran was doing this for a long time at Stanford in a very realistic, practical way, and driving, AI safety, I think, before AI safety became this other thing.
Well, I mean, along similar lines, I think the insights that you've had, Andrew, and the work that you've done, including like testimony to the Senate around things like looking at what are the problems people are trying to address and the tasks rather than just the technology from a regulation standpoint, really kind of gets at that notion of what are the realistic downstream things we are trying to manage and deal with? And those are the things that we should keep our eye on, because that's what's going to have the real impact, rather than either worrying about doomsday scenarios or worrying about just technology getting more powerful. Technology will get more powerful. That is not that's not up for debate. That's just a given. But how we use that technology is one of the critical factors to think about for its regulation.
Yeah, fully agree.
Building on that, maybe Andrew, for you, just thinking about, you were talking about how coding is now, you're saying everyone should learn to code. It's this fundamental skill, and maybe even extrapolating or building on it, saying it's kind of that, as you were saying, Mehran, it's a problem-solving strategy. How do you decompose a problem into its specific tasks or challenges? So I guess where do you see, Andrew, the kind of the value of domain knowledge within that? I mean, is that, again, there have been lots of research, even going back to just the internet and Google, where people, when you can search anything on Google, you vastly overrate how much you know, because it's not in your brain, but it's in this extension of your brain online. So, and I've heard similar sort of, not actually in the computer science department, from other departments, that you're seeing a lot of even graduate students who come in and they have a very deep knowledge of, say, data science and statistical methods, but they might have lost some of that core domain knowledge within whatever their field is. So I'm wondering, where do you see that kind of, as more people have access to these skills, or to these kind of computational methods, or to LLMs, where do you see that role of domain knowledge? I mean, are we going to need more people with deep knowledge of policy, not just kind of at this problem solving at the very practical level? What are the laws that are out there? Where does that go? Where does domain knowledge go in this mix?
Yeah, so think about AI. I think AI is most exciting and creates the most value when we can apply to something. I think AI technology in isolation, is like, I don't know, just pretty useless, frankly, until we figure out a way to apply it to something that actually matters. Because AI is a general purpose technology, there are opportunities to identify compelling use cases pretty much everywhere across the economy, right? In healthcare, education, financial services, logistics, and on and on and on. And I find that a lot of the most exciting projects I get to work on is when I, as an AI person, get to collaborate with someone with deep domain knowledge in some other sector that often I know nothing about or very little about, and that I really don't have a right to play in, but for our collaboration. So in fact, some of my students at Stanford do a lot of work on AI applied to healthcare. And, candidly, I think I know a little bit about healthcare, learned a lot in the last several years of collaboration, but candidly, compared to a physician over in the School of Medicine, my knowledge is so minuscule relative to a full-time doctor studying this for a long time. But I find those collaborations where AI person with deep tech knowledge collaborates with a healthcare deep expert or some other expert, that often creates the opportunities to apply things that are very exciting.
Ron, is there anything you would add to that? I know the CS department, I mean, you have a lot of those kind of specializations even, or they're in their other departments that are kind of computational at their core, but also domain specific, like biomedical data science or computational biology within. Yeah.
I think Andrew hit it right on the head, right? Is when you want to solve particular problems in a domain, you need to have some domain knowledge to understand kind of what are the interesting problems to solve, what are the worthwhile problems to solve, what are approaches that have been taken in the past that maybe were more or less successful. So if you think about the full spectrum of ways you could approach a problem, it's huge. And having some domain knowledge, what it gives you is a way to be able to narrow down on some of the things that have greater probability of success, and then collaborating with people who might have computational skills or might have skills in other areas to be able to further winnow down what kind of techniques you might want to use, how you can address those problems in a more effective way. And also just broadening horizons. I mean, Andrew talked about the example of medicine, which I think is a huge, huge area, healthcare, for where we might see potential benefits for AI in the future. One of the things I've been collaborating, areas I've been collaborating with in the past couple of years is with a couple of political scientists on areas of policy, right? And there's lots of things about just the policymaking process, or how they think about policy, or how you think about like harms-based frameworks versus rights-based frameworks, that I didn't know very much about at all, right? But I could provide a little bit of a technical perspective to then think about, okay, if we're going to talk about some kind of issue like, let's say, privacy, how do we think about the value trade-offs involved relative to what the technology can do with trying to preserve some of those values? And what does that mean in terms of crafting something that is meaningful from the standpoint of policy? And I think the fact that we could bring kind of domain knowledge from our different domains together to have that conversation to try to push the ball forward in a particular area really showed the value of that domain knowledge. There's no way I would have had an understanding of those issues in the same way if I hadn't been able to have conversations with people who had real domain expertise and background knowledge in those areas.
Yeah, and one interesting rub that a dynamic I'm seeing that is exciting and stressful is earlier I mentioned, Gen AI is letting a lot of teams do things much faster, and because AI and CS is integrating with so many industries, the very fast cadence that CS can drive is now pushing, creating some stress, frankly, for a lot of other industries to move faster as well. So take healthcare, FDA approval, whatever, 6 months or even like years. But now CS people, even more so because of Gen AI, have the capacity to build applications in days or weeks or whatever that would have previously have taken months. There's actually a lot of AI applications that would have taken me like a year to build, that today there are probably hundreds of thousands of people that can build in a weekend, what used to take me a year because of new technology. And this, and I know that move fast and break things got a bad rep because some people move fast and they broke stuff, and that was kind of a problem. But I think there are also ways to move fast and be responsible. And one of the frameworks is sometimes you can move fast, but to quote Jeff Bezos, with a two-way door rather than a one-way door. If you can make sure you can move fast but not break things, there are a lot of ways to write software, experiment, do so in a responsible way that doesn't harm others. But when you have those processes, I find that in a lot of applications in industry sectors, you can actually move really fast. And so I end up talking a lot to, large companies, C-suite, or boards ask me to do sometimes chat with whatever on how to go to different industries outside tech, be it manufacturing or healthcare or something else totally different, to think through how this speed that is now possible in computer science and in AI, which has also infiltrated these industries, what are the new corporate processes to do things quickly? Because candidly, if you do things slowly because of the natural cadence of the industry, but there are competitors and now get stuff done in a week that you take a year to do, right? That creates a challenging dynamic. So I see CS and AI with the speed that Gen AI is enabling, we are maybe, honestly, I think we're actually stressing a lot of people, I'm being honest. I'm very sympathetic to a lot of people being stressed out. And I do get it that it is challenging, but I think working this through together could help a lot of industries and a lot of people be much better off.
Do you think some of that, we're a little bit over time, so I want to respect your time, but Andrew, just as a quick follow-up to that, do you think that part of that stress is we're talking about coding and education. Do you think part of it is there aren't enough CS majors, or is it that enough, or is it just, if we had more people taking CS 106A and B, we'd be able to tackle some of these problems? I mean, is that one of the bottlenecks to this speed, is just the number of people with the technical background?
Massive shortage in people that can that have the skills to build and execute AI projects. I know that the job market for CS jobs has its ups and downs, but people that are truly skilled, there just aren't nearly enough of truly skilled people. And taking CS 106A and CS 106X is a wonderful first step to being highly skilled in CS.
Thanks for the plug, Andrew. I mean, one thing I would just to add to that, I do think Andrew's exactly right. But is the notion people oftentimes ask, so is AI going to create jobs, or is it going to have people be unemployed? Is it going to destroy jobs? And I remember being asked this question in a group by a group of tech CEOs. And my response to them was, AI is neither going to create or destroy jobs. You are going to create or destroy jobs. What AI is going to do is it's going to be an enabling technology that might change what the productivity landscape looks like. There's a question of how human beings then decide they want to essentially internalize those gains or losses of that productivity. So just a simple example, imagine that AI, you use generative AI in coding in a software organization, and it makes the whole software organization 20% more productive. And some executive somewhere has to decide, what do you do with that 20% productivity gain? Do you go after 20% more product, more features, more stuff that you build? Or do you have a 20% smaller labor force in your engineering staff? Right? That's a human decision. That's not AI's decision. And so one of the things we always need to keep in mind is that AI is going to change what the landscape looks like in terms of how efficiently and productive people can be, but there will still be human decisions as to how those productivity gains are harnessed with respect to solving bigger problems or going after bigger tasks.
So that's wonderful. And I just kind of summarizing what I've heard from the three of you is this, I really like this phrase for the three of you, the two of you, is move fast and be responsible. I like that a lot, Andrew, and this idea that, you know, what is AI is kind of opening up the landscape, Mehran, of the decisions that we are able to make. It's opening up the kinds of decisions we can make and how to deploy resources effectively. And finally, I guess on that education front is, yeah, learn to code. Everyone should be learning to code and learning how to think computationally and how to break a problem down in a systematic way. I guess as we're ending here, is there anything you haven't had a chance to say or you want to add at this point? Mehran, anything you would want to add?
Well, I mean, there's tons of stuff to add, but given that we only have a few minutes left, I think the point is that in the overall balance of anxiety that AI produces versus opportunity that produces, I think if someone can remain focused on the opportunity, but it also behooves us as individuals to continue to refresh our skills. Like as Andrew mentioned, one of the things that AI does is it is an accelerant. It makes things move faster, and that means it puts an onus on us to also move faster to be able to help keep up with those changes. But if we can, I think the opportunities are huge.
That's great. Yeah. Andrew, anything you'd want to add?
Yeah, you gave a masterful summary, Pax, and maybe I think the democratization and set of new opportunities available for everyone with AI is vast. Today, there are a lot of job roles where I can't imagine hiring someone that doesn't know how to use web search. You know, it's just like, can you be a marketer, recruiter, or whatever if you don't know how to use the internet? It's just hard to imagine for most companies. I think that we will get to a point where to be effective in many job roles, being able to use AI, maybe even be able to write a little bit of code, will be a huge advantage. I think, you know, I was working on an online course, AI Python for beginners, to try to teach some of those skills. But I feel like it is so exciting to see friends learn a little bit of code and then deploy really valuable applications in, you know, days or weeks that are not traditional software engineers. So I think there are a lot of opportunities for strong software engineers to be even more productive. I just can't imagine software engineers in the future not using AI. I think there are also a lot of opportunities for really everyone, not just software engineers, to make computers now do stuff for you that previously would have been really difficult. And the trends are AI is making it much easier for you to write code, even if you're not a software engineer. And it turns out many people can now write AI applications, meaning that you can use code that calls on some other AI system to get a lot done for you. So for the near future, I think low code, where you know a little bit of coding, will be much more powerful than no code, where you don't use any coding at all. And I think the challenge will be, how do we help everyone? Just like a lot of people had to learn to use the internet, and people that maybe learned to do it faster, you know, got more stuff done quickly. I do think there's a big societal-wide challenge now that this wonderful, so low-cost tool is now available, you know, to help a lot of people to learn to take advantage of this for themselves and the families and the communities.
Thank you both. And we're really fortunate to have the two of you leading that effort to educate the world on how to do that. So thank you both. Thank you, everyone who joined. We worked a lot of those questions into the Q&A, but I know there were a lot more that came in. So thank you again. And finally, as I said, a recording will be sent out in about a week. And if you want to learn more about the kinds of courses that Andrew and Mehran teach, again, look at the resources right on the right-hand side of your console and feel free to click on them. Thank you both for joining us today. We really appreciate it. That was a wonderful discussion. I'm sorry we ran a little bit over. It was very exciting. So.
Yeah. Thanks, everyone.
Thanks,
Mehran. Thanks.